Okay, now we'll look at matrices as transforming the plane. Okay, and what I mean by that is we have a vector here and a matrix. We can multiply them together. Let's do that. Excuse me. We got 4 minus 1, so we've got 3. Then we've got minus 4 plus 6, so 2. So when you multiply them together, you get 3, 2. So what this says is I started with 2, 1, like this, and after I multiply it by this matrix A, I get 1, 2, 3, 1, 2, this vector. So you see it maps this first vector onto that second vector, like that. So we can view matrices as maps from this plane here, for this 2 by 2 matrix, from the plane to the plane. So it will take vectors and map them to other vectors. We can ask what the effect a matrix has on the entire plane. Okay? And of course I've made a little Desmos demonstration here. Let's clean it up a little bit. So let's look at that first matrix, 2, 3, 1, 2. And now the way I'm going to do this is I'm going to imagine a square here, a unit square. And when I multiply it by this matrix, multiply each of the vertices by this matrix, I want to see what the resulting image is. So if I multiply 1, 0, for example, by that matrix, I can ask where it ends up, and the same with 0, 1, I can ask where it ends up, and watch where this one ends up as well. So now our matrix was 2, 3, 1, 2, so if I multiplied it by 1, 0, I'd end up at 2, 1, and by 0, 1, I'd end up at 3, 2. And that's what I've got right here. So you can see the effect of that matrix. When I take this original unit square and I multiply it by that matrix, it stretches it out. So this side here is this side after it's multiplied. This side ends up here, and so on. This side ends up here, and the top is this little bit right here. So you see, it moves that square around, but you can imagine it's like squishing and stretching out the entire plane. That's the effect of that. Now let's look at this one. Negative 1, negative 2, negative 4, 1. So if I multiplied that by 1, 0, I'd get negative 1, negative 4. If I multiplied it by 0, 1, I'd get negative 2, 1. And that's this one right here. Okay? So you see, the origin, of course, is fixed because it's 0, 0. Multiply it by anything, I'll get 0 back. This corner ends up all the way down there. 1, 0, it ends up, where was that again? Negative 1, negative 4. So it ends up all the way down here. And this one goes over here. So you can see it kind of moves the square over, but also kind of flips it, turns it inside out. Okay? So that's what's happening to this plane here. It starts off as a plane, it kind of flips over, gets stretched out a bit. Okay? So that's the effect of multiplying by that matrix. Here's some practice problems for you that you can try out on your own, and we can talk about next time we meet. And let's try to draw out what we just did, just as another perspective on it. So when I multiply 1, 0 by this, I'm going to get negative 1, 3. And if I multiply this by 0, 1, I get, well, the same thing, 0, 1. Okay, so I can start drawing it. Initially I have 1, 0, so I'm going to just draw it like this. label that as A. And then it goes to -1, 1, 2, 3, all the way up here. And I'll just put A prime. So just ends up here. And at 0, 1, this is where I start and this is where I end up. So you can imagine if I had a box, it starts here, but then this matrix or this vector that I labeled A kind of gets flipped and stretched up over here. Okay, so you can see it kind of flips along the vertical axis and then stretches it vertically. Okay, so it leads to a question of how can we do that in general? How could we get a horizontal stretch by a factor of k for some constant, or maybe a vertical stretch? Or how could we get a reflection about the vertical axis or about the horizontal axis? That sort of thing. Okay. We could, of course, go back to Desmos here. Let's hide those guys. I've got the effect of multiplying by the vector or by the matrix A, B, C, D. So I have there I have the image, the effect of multiplying this square by this matrix. I have it loaded in this polygon. So we can see what happens when I change the entries of A, B, C, and D. So far I've got A is 1, B is 0, C is 0, and D is 1. So it's just the identity matrix now. Now let's see what happens when I increase A. Sure enough, gives me a horizontal stretch. If I decrease it and decrease it down past 0, let's change this color here so we can see its effect more clearly. You see it gives a negative stretch, so it's kind of like flipping about the vertical here. Let's return it to its position. Now let's play with D a bit, see what happens here. Get a vertical stretch, and sure enough, this negative vertical stretch. Now let's look at the two off terms. So if I put C here, or no, let's start with B. If I put B, increase B, see what happens. I give it a bit of a, what's called a shear, a horizontal shear, like that. Return to start, if I can. There we go. And let's see what we have with C. I think you can anticipate what we'll have. We should have a vertical shear, sure enough. And then what we could do is we could, combine them, see what happens. So here we have both a vertical and a horizontal shear. Then I could do this, and it's going to stretch, so it's sheared and stretched. Same over here. So you see the effect of combining these different values, we can get different outcomes for the square. Great. So let's go back here. I've got that summarized with these screenshots from our text. Okay. We saw that when we changed this A value, we got a horizontal stretch, vertical stretch, changing that D value, horizontal shear, changing B, and sure enough, vertical shear by changing C. And there's many other transformations we can see, and we'll play with those in time too. Okay, now we want to combine things, kind of like what we just did in Desmos. So I want to find a matrix that stretched the plane horizontally by 3, so it stretches it out, vertically by 2, and then flips the plane about the y-axis. So one way we could do this is just kind of consult this here. We see that a horizontal stretch is going to be this value here. So if we're looking for a horizontal stretch, we should perhaps have a 3 in this position. Now for a vertical stretch, We see it's a number here. So we should put a 2 there in this case. And then we also needed this horizontal, if you want to call it horizontal, a reflection about the vertical axis, which is done right here. So you see we have just a negative. So the matrix we're looking for should look like this. We should have a horizontal stretch by a factor of 3, a vertical stretch by a factor of 2, and then just a negative here to get that reflection about the vertical axis. Okay? So we should have this vector. Another way we could do this is multiply these corresponding matrices together. So a horizontal stretch we saw already is 3, 0, 0, 1. A vertical stretch is 1, 0, 0, 2. And a flip, we just have to go -1, 1. Okay, so we could imagine to transform that square, we could first stretch it by 3, then up by 2, and then flipping it. So you imagine you're applying these matrices sequentially. So we would have our horizontal stretch, followed by our vertical stretch, followed by a flip about the vertical axis. So we can actually multiply these through and see what we get. Let's do this one first. So it's going to be -1, 0, 0, 1. Okay, and then this is going to be 3, 0, 0, 2. Okay, when I multiply these, I get -3, 0, 0, 2, which is what I expected. So you can imagine you can pick the entries that correspond to the transformation that you want, or you could imagine sequentially applying those transformations and get this resulting transformation matrix. Okay, I've given you some practice problems there, and we can try them when we get together again, but I think that should give you a good start.